All right, we're going to work with some function operations, which means that we're going to add, subtract, multiply, and even divide these until we can figure out what's going on with them. Okay, so we're going to go way back just a little bit. We're going to add some like terms. So first thing is function notation. It means I want to take f of x, which is 4x plus 7, and I want to add to that the square root of x plus x. I'm going to use parentheses here just showing that we're doing substitution, so it's not a big deal. After that, I have 4x and an x, so that makes, by addition, 5x. I have the square root of x, which is all by itself, and I have a 7, and these are all unlike terms, so no big deal with that. So make that number 1. Number 2, this is going to be our subtraction, so same thing that I have here, 4x plus 7. You just need to subtract the square root of x plus x. So here's where we want to be careful, just like you did in Algebra 1. We want to make this minus the square root of x minus x, giving us an end result. So 4x minus x is 3x. This time I have minus the square root of x because we had distributed that negative sign, and then plus 7. Okay, the remaining question is about domains. So this is where things get a little bit trickier. But all we have to do is realize that the very first function f of x is a line, so its domain is all real numbers. In the second function, we have a square root of x, which means we cannot take the square root of a negative. So that means the domain is x has to be greater than or equal to 0. Since both the results still have a square root of x, that makes the domain of both of these x is greater than or equal to 0. Okay, so that's the key. If you're dealing with a square root, it's going to end up being greater than or equal to 0, unless we have some more things inside of that function. Okay? But today, our focus is really just add, subtract, multiply, and divide these functions. Having said that, let's move into adding and subtracting from multiplying and dividing. So if we want to multiply, we have a couple of different ways to show that. One way is to put this little multiplication in there. Notice this sign right here, it's all closed in. Okay, this is the same thing as saying that you're going to take f of x and multiply it by g of x. So when you see that, hopefully this brings to mind FOIL. Okay, so we're going to take the first, now it becomes x cubed. We're going to take the outside, which becomes 3x squared. We're going to take the inside, which becomes minus 9x, and minus 27. So this is the result of multiplying. As we take a look at the domain, we know the domain for x squared is going to be all real numbers because it's a parabola, and we'd already discussed that x plus 3 is a line, and we get up to x cubed, it's still going to be all real numbers. All right, second problem we have is to do some division. So I have x squared minus 9, that's f of x. It's over top of x plus 3. So the real question is, how do I factor x squared minus 9? Well, that's x plus 3 and x minus 3. It's one of the special cases. On the denominator, I have x plus 3. Now that we have factors in the numerator, this can be reduced. So my final answer is x minus 3. We have a little catch about the domain, though. I have to watch that in my original problem, the denominator cannot be 0. So I'm going to take this part and solve it for 0 by subtracting 3. So x cannot be negative 3. Okay? Anytime we have a fraction, that's going to create a domain restriction. So our division is going to be the one that's a little bit more difficult to identify, or maybe it's easier, depending on how you think about it. Whatever you put in the denominator, set it equal to 0. If you can get a real number for it, that's your domain restriction. It's allowed to be everything else, though. Okay, so we have two parts to do. We have to actually do the division, which I have laid out in yellow here, and then we have the domain restriction, which is laid out in red. All right. One other thing that you should have done in Algebra 1 is a composition of functions. So I zoom in here and just show that we have just this ton of parentheses going back and forth. And how this works is we're going to take g of x, whatever that is, even with a number and result, and put that into the next function. So if we start on the inside, so in this one is telling me to solve for f of x and then put that into g of x. So we always want to start on the inside and work our way out. And that's what's laid out here. So the notation I have circled in yellow is what we use in Algebra 1. As you get different Algebra 2 textbooks, they might use now an open circle. Remember, I pointed out before that we had a closed circle. That meant to multiply. If it's an open circle, that means to take a composition, which means we're going to take one function and put it inside of the other. Here's how it works. All right, so first thing I'm going to do is find out what is f of negative 3. So f of negative 3 is negative 3 minus 5. That result is negative 8. Now that's saying put that into g. So here's what I like to do. So I say g of negative 8 means negative 8 squared. So the final answer here is 64. So we're going to like those a lot better because we're working with a number. It's not very confusing or trying to figure out what's going on. Like I said, that's a change in notation, but exactly the same thing you should have been asked to do in Algebra 1. So what else can I ask you to do in Algebra 2 with it? Leave it as the function that it is. So f of x needs to go into g. So I need g of x minus 5. So I want x minus 5 squared because the function g was just x squared. So I'm replacing that with f of x. So that means we need x minus 5 times x minus 5. So I get x squared minus 5x plus 25. So our end result is x squared minus 10x plus 25. What if we had negative 2 times that same thing? I'm going to take f of x and put it into g of x. Well, let's not be redundant here. We just found this answer. That's x squared minus 10x plus 25. So the last thing I would do is multiply it by negative 2. So negative 2x squared plus 20x minus 50. That gives me my end result. Now, the order does matter, right? So that's the other part that was laid out here. This is not commutative, right? Remember, commutative property, home to school, school to home, that means either way it works. This does not work that way. So D is the one that kind of proves that. So this time what we'd like to do is take g of x, which is x squared, and put it into f of x. So we're going to do f of x squared is what we're trying to do here. And remember, that was x minus 5. So now it's x squared minus 5, and it's done. Okay, x squared and 5 are unlike terms. There's nothing else we can do. All we've done is we replaced where we had x, and we put in x squared. Okay, so notice these are not the same, and they do not provide the same result. All right, a couple things we want to lay out here, and then you can help me out with some answers as we look at these. So, in number 1, it's all closed up. So do you want to add? No. Do you want to multiply? Or do you want to do a composition? All right, hopefully we want to multiply. We got 3x minus 2, and we have x squared plus 1. We're simply going to FOIL this together to get our answer. Three x cubed. On the inside, I get minus 2x squared plus 3x on the outside and minus 2. These are unlike terms, so we get to stop there. Number 2. So notice a change in notation. This time we want to subtract. Remember, anytime we want to subtract or add functions, We typically want to use parentheses just to help with distributing. We do want to start with f of x, so 3x minus 2 minus x squared plus 1. While I do this, I'm thinking about distributing the negative, so it becomes negative x squared minus 1. So negative x squared is my first term. The 3x is positive, and now I have negative 2 and negative 1 to get negative 3 as a final answer. All right, number 3. This one had that open circle to it. So the notation could look like this from Algebra 1. So I want to take g of x and put it inside of f of x. So 3, in place of the x, I want to put in g of x. What was g of x? X squared plus 1, and then minus 2. Distribute the 3 and combine like terms. Leaves us with a result, 3x squared plus 1. Final answer. All right, the only thing that's really missing here is an addition problem, so we'll finish that out with number 4. So we want f of x, remember that's 3x minus 2, and we're going to add to that x squared plus 1. Looking for like terms, all I have is x squared, then I have 3x, it is positive, and negative 2 plus 1 is negative 1, so that gives us our addition. Number 5, we've changed the order, and number 6 is exactly the same with a different notation as number 2, so we definitely won't do that one. All right, we have a couple problems highlighted here, and we're going to give you some time to work on and submit some answers. So 47, good. 51, there's the order, and in the end, we're eventually just going to add 10 to whatever your result is. And it wouldn't be a fun day if we didn't do one of our divisions. All right, the last one we're going to deal with is number 76. Now I'm going to do this as f of g of x and get a result, and g of f of x and get a result.